Welcome everyone. I am K.S.Rangasamy, Assistant Professor in Department of Electronics Engineering with specialization in VLSI Design and Technology. In this lecture, we are going to discuss on Introduction to Embedded System, which is a part of our syllabus. In this session, we will understand what an embedded system is, its architecture and components, types of embedded systems, application across various domains, programming tools, design constraints, and future trends. Let us begin with the basic definition. Generally, an embedded system, which is a system combining hardware and software designed for dedicated function. Generally, it is a special purpose computer system that combines hardware and software to perform a dedicated function. Unlike a general purpose computer such as laptop or desktop, an embedded system is designed for one specific task. Let us see the important characteristics of an embedded system. It is a single functioned, which means it performs only one predefined task which is already programmed. It is tightly constrained in terms of power, money, and cost. It is usually work in real time, responding with in a fixed time, and also it consumes very less power when compared to other higher end devices. It is highly reliable since failure may cause serious consequences. So the next thing is the importance of embedded systems. Embedded systems are everywhere around us. They are widely used in consumer electronics, healthcare systems, automotive electronics, and industrial automation. In fact, the most modern electronic products cannot function without an embedded system. Next, we are going to discuss with basic architecture and components of an embedded system. An embedded system mainly consists of four major components. Processor. A processor is the brain of an embedded system. Common processor, which includes microcontroller used in low cost and low power systems. Microprocessors when high processing power is required. Digital signal processors used for signal processing applications. Processor may follow what hardware or van Neumann architectures. It is selected based on the applications. Suppose if you are choosing a hardware architecture, we need a separate memory for data and instructions. And on the other hand, if your van Neumann architecture is used, common memory for data and instructions. Next thing, memory. Memory generally stores the data and programs. We have different types of memories: RAM, ROM, flash memories, EEPROM memories, and etc. Generally, the RAM is used for temporary storage during execution. ROM, it stores firmware permanently, and the EEPROM, it's used for storing configuration data. The next thing is peripherals. The peripherals are the external devices which is used to collect the real world data, and it is connected with the external worlds. Generally, we have sensors, actuators, input-output interfaces, digital to analog as well as analog to digital conversions. The sensors which senses the physical systems and converted in the electrical signals, and it performs some operations from inside the microcontroller, and it actuates the other signals based on the conditions given. The next one is software. Software is a firmware, low level controlled software. Generally, the RTOS, real time operating systems for task scheduling application programs, perform user defined functions. So these are the different basic components that is commonly inbuilt in the embedded system. So in this diagram, we have seen the clock controller, GPIO, UART, SPI, I2C, timer, ADC, DAC, flash memories, cache memories, SRAM. So everything is placed here to perform a dedicated functionality based on the applications. Next, we are going to discuss on types of embedded systems. So generally, embedded systems are classified into different types based on the functionality. The first one is the standalone systems. The standalone systems, the name itself you can clearly understand, the systems can operate independently. Examples are washing machines and calculators. The next one is the real-time embedded system. These systems must respond within a specific time. The real-time embedded systems are further classified into hard real-time systems and soft real-time systems. The hard real-time systems, which means missing a deadline, may cause failures. Examples: valve control systems. On the other hand, the soft real-time systems, the minor delay is acceptable. Examples are DVD players. So the networked embedded systems. The networked embedded systems are connected through the networks for communications. Examples: web camera, home automation systems, and industrial monitoring systems. The next one is the mobile embedded systems. The mobile embedded systems are presently have a huge market, which is portable systems with limited power. So examples: the smartphones and PDAs. So these are the different types of embedded systems which we are using it day to day life. The next we are going to discuss on application across various domains. Yeah, embedded systems are used across various application domains based on the necessity it is used in these applications. The first one is the consumer electronics. In consumer electronics, we are using the embedded system in our day-to-day life, like digital cameras, smart TVs, microwave ovens, etc. And if you come into automotive systems, we are using the embedded systems across engine management, airbag control units, anti-lock braking systems. In the medical systems, the embedded system is used in pacemakers, patient monitoring systems, medical imaging devices, etc. Industrial application, it is mainly used in controlling the robots, CNC machines, and the process automation applications. And also it is used in IoT enabled systems nowadays. Like we are using the embedded systems to make smart homes, health monitoring systems, and IoT gateways. Thus, embedded systems from the backbone of the modern technology. Next, we are going to discuss on embedded system programming and tools. Generally, the embedded system programming and tools are discussed in this session. Generally, it is programmed using the commonly used languages. It includes C, embedded C++, C++, assembly language, and ADA. Among this, embedded C is most widely used because it is easy to program. And if you come across the development tools, we have integrated development environments, cross compilers, debuggers, and in circuit emulators. These tools helps in efficient development, testing, and debugging of embedded applications. Next, we are going to discuss on design considerations and constraints. Embedded systems mainly involves several constraints because we are going to operate a system with limited amount of power. So the first thing is power management, especially the embedded systems are used for battery operated devices. Next one is the memory limitations. We have optimized code and data usage, real time response which includes meeting strict deadlines, and low cost mass production constraints, and the reliabilities. The system should work continuously without failures. And modern embedded development also includes embedded DevOps and multi-core development, automated hardware in-loop testing, low power and energy efficient designs to meet the considerations of the consideration and constraints of the users. Next, we are going to discuss on the case studies and future example trends of the embedded systems. Let us briefly look at some examples. Case studies. So that is Apollo guidance computer, the early space embedded systems, the home appliances like washing machines and microwave ovens, IoT enabled kiosks, and environmental monitoring systems. If you go into the future trends, we have advanced microcontrollers, IoT integrated embedded systems, and cloud connected embedded systems, real time systems with predictive analysis, AI driven embedded devices. So these are the things that we have developed so far in this embedded systems. Next, we come to the conclusions. Like, to conclude, the embedded systems are specifically specialized computing system that plays a vital role in modern technology. Understanding their architecture, application, and constraints is essential for engineers. So, thank you for listening. We will continue with more detailed concepts in the next lecture. Thank you.